AI vulnerability discovery goes industrial. Claude Opus 4.6 just found 22 zero-day vulnerabilities in Firefox in 2 weeks. 14 of them were classified high severity. Nearly a fifth of all high-severity Firefox CVEs remediated in 2025. Anthropic's collaboration with Mozilla started as a benchmark exercise. Could Claude reproduce known CVEs in older Firefox codebases? It could, at a surprisingly high rate. So they pointed it at the current codebase. Within 20 minutes, Claude reported its first use-after-free vulnerability in Firefox's JavaScript engine. By the time Anthropic's researchers finished validating that first bug, the model had already found 50 more unique crashing inputs. Mozilla, to their credit, encouraged bulk submission without per-bug validation, and Anthropic ultimately filed 112 unique reports after scanning nearly 6,000 C++ files. Most fixes shipped in Firefox 148.0 to hundreds of millions of users. The more sobering finding is on the exploit side. Anthropic tested whether Claude could turn discovered vulnerabilities into working exploits. Actual read/write primitives on a target system. After several hundred attempts at roughly $4,000 in API credits, Opus 4.6 succeeded in only 2 cases, and only against a test environment with security features intentionally stripped. The sandbox, the real defense in-depth layer, would have stopped both. But the gap between finds bugs brilliantly and can sometimes write crude exploits is narrowing. Anthropic's own assessment. It is unlikely the exploitation gap lasts long. The window where defenders have the advantage is still here, but it has an expiration date. Into that window steps OpenAnt, an open-source LLM-based vulnerability scanner released by Gnostic under Apache 2.0. OpenAnt runs a 2-stage pipeline. Stage 1 detects potential vulnerabilities. Stage 2 simulates exploitation. Only findings that survive both stages surface as verified results. It supports Go and Python as stable targets, with JavaScript, C/C++, PHP, and Ruby in beta, and requires a Claude Opus 4.6 API key for its analysis engine. Gnostic has explicitly positioned OpenAnt as complementary to, not competing with, Anthropic's Claude Code Security and OpenAI's Codex Security, framing it as a community tool for open-source maintainers who lack access to commercial scanners. The timing is deliberate. As AI-discovered vulnerabilities proliferate, defenders need tools that are accessible, not just powerful. Gnostic is already in coordinated disclosure for findings uncovered during OpenAnt's development, which suggests the tool has already found real bugs in real projects. PentAGI has also emerged as a fully autonomous AI penetration testing platform. Built in Go with a React front end, it deploys specialized AI agents that collaborate on reconnaissance, exploitation, and reporting, all within sandboxed Docker environments. It integrates with 20-plus professional security tools Nmap, Metasploit, Skullmap, supports 8 LLM providers, and uses a Neo4j knowledge graph for semantic relationship tracking across engagements. The project has attracted attention from security researchers who see it as a preview of where offensive AI is heading. Specialized agents coordinating attack strategies autonomously, with humans supervising rather than directing. Supply chain attacks meet AI agents. On February 17th, someone published Cline at 2 true day 0 to npm. The binary was byte identical to the previous version. The only change was one line in package.json, a post-install hook that silently installed OpenClaw, a separate AI agent with full system access, on every developer machine that ran npm install. Approximately 4,000 downloads occurred before the package was pulled. The interesting part is not the payload. It is how the attacker got the npm token. They injected a prompt into a GitHub issue title. Cline's AI triage bot, running Anthropic's Claude Code action with allowed non-write users, read the title, interpret it as an instruction, and executed npm install from a type-squatted repository. The attacker's fork deployed Cacheract, a cache poisoning tool that flooded GitHub's LRU cache with junk data, evicting legitimate entries. When Cline's nightly release workflow restored node modules from cache, it got the compromised version. Along with the npm release token, VSCEPAT on OVSXPAT. All 3 were exfiltrated. The chain is 5 well-understood vulnerabilities composed into one exploit that requires nothing more than opening a GitHub issue. Prompt injection, cache poisoning, credential theft, malicious publish. And the kicker. A security researcher named Adnan Khan had actually discovered and reported the vulnerability chain on January 1st, over 5 weeks before the attack. None of his follow-ups received a response. When he publicly disclosed on February 9th, Cline patched within 30 minutes, but then deleted the wrong token during rotation, leaving the exposed one active for 6 more days. The attacker exploited a proof of concept from Khan's test repository. The remediation is meaningful. Cline has adopted OIDC provenance attestations for npm publishing, which would have prevented the attack entirely since a stolen token cannot publish packages when provenance requires cryptographic attestation from a specific GitHub Actions workflow. But the architectural lesson is broader. Every team deploying AI agents in CI/CD, for issue triage, code review, automated testing, has this same exposure. The agent processes untrusted input and has access to secrets. The question is whether anything evaluates what the agent does with that access. Governing the agent fleet, the Cline injection attack exposed a gap that 4 separate pieces this week attempt to name and fill. Agents have identity, authorization, and delegation. But nothing governs whether the mission behind the request should still be running. Carl McGinnis frames this as the difference between a passport and power of attorney. Identity controls answer who is acting. Access controls answer what they are allowed to do. But no layer in the modern IAM stack asks, should this execution still be running at all? His proposed artifact, the execution mandate, is assigned, independently revocable record carrying the purpose for which authority was granted, the conditions under which it holds, and the lifecycle events that end it. The example is pointed. An agent pulling pre-IPO financials at 2:05 p.m. on a mandate that expired when the board approved the presentation at 2 p.m. Token valid. Authorization passed. Mandate expired. Nothing in the stack can see it. A Porv Garg at Orva extends this from identity into runtime. His agent security lifecycle has 6 stages: discover, govern, contract, monitor, enforce, learn. The critical insight is that most agent incidents will not start with an unknown agent. They will start with a known, approved agent that drifted. Permissions bound access but do not bound decision-making. An approved agent can stay inside granted scopes and still pull far more data than expected. Chain through tools so effective privilege becomes the union of multiple identities, or route output to a destination nobody modeled. His 6 primitives for making drift measurable: actor, tool, action, data, destination, purpose. Form a shared vocabulary between governance and runtime evidence. Without both, he argues, you have either governance theater or noise. Stuart Wintertier takes the question upstream to the boardroom. Agents do not just raise capability, they raise obligation. A copilot can be mostly harmless. An agent that has been handed verbs, approve, route, refund, provision, creates exposure the moment it acts. His 5-part proof standard: value, risk, control, cost. Adoption is designed for the gap between demo and scale commitment. The refund agent example is concrete. Reduced cost per case over a full month. Refund error rate below threshold. Hard cap on amounts. Auto-pause triggers for anomalies. Time to stop measured in minutes, not hours. Every action logged to a reviewable ledger. That is underwritable. Without it, you are scaling exposure, not capability. On the monitoring side, Aegis positions itself as EDR for AI agents. Endpoint detection and response applied to what AI does on your local machine. It tracks 107 known agent signatures. Monitors file access to .ASHI, AUS.27 AI agent config directories, captures outbound TCP per agent PID, and builds rolling 10-session behavioral baselines with 4-axis anomaly scoring. Built on Electron and Svelte with 568 tests, it is entirely local. No cloud, no telemetry. With autonomous agents like OpenClaw gaining access to local files, credentials, and shell, someone needs to watch what they do. Plausible code versus correct code. A detailed analysis of an LLM-generated SQLite reimplementation in Rust reveals a failure mode that should worry anyone relying on AI-generated code without rigorous benchmarks. The reimplementation is 576,000 lines of Rust across 625 files. It has a parser planner, VDB, bytecode engine, B-tree, pager, and wall. It compiles. It passes all its tests. It reads and writes the correct SQLite file format. And a primary key lookup on 100 rows takes 1,815 milliseconds, compared to SQLite's 0.09 milliseconds. That is 20,171 times slower on one of the most basic database operations. 2 bugs and a cascade of safe defaults compound into the result. Bug 1. The query planner's isRoid-ref function only recognizes 3 magic strings roid, oid, but never checks whether a column declared as integer primary key EY, the standard SQLite pattern, maps to a roid. Every her ID equals sign n query does a full table scan instead of a B-tree seek. ON instead of O-login. Bug 2. Every bare insert outside a transaction triggers a full fsync, where SQLite uses fdatasync data-only sync, skipping metadata. These are amplified by AST cloning on every cache hit, 4 KB heap allocations on every page read, schema reload on every autocommit cycle, and eager formatting in the hot path. Each decision sounds individually reasonable. We clone because Rust ownership makes shared references complex, but the compound result is 2,900x slower at baseline. The analysis connects this to RLHF sycophancy. Models trained on preference data learn to reward agreement over correctness. GPT-5 produces sycophantic proofs of false theorems 29% of the time when the user implies the statement is true. In code generation, this manifests as agents that never push back with "have you considered," but instead enthusiastically generate whatever was described, even when the description was incomplete. The author's conclusion: LLMs work best when the user defines acceptance criteria before the first line is generated. The code is not yours until you understand it well enough to break it. Running in the opposite direction. A research paper from TU Darmstadt demonstrates what happens when you lean into LLM code synthesis with proper structure. Bespoke OLAP uses an automated pipeline to synthesize workload-specific database engines from scratch. Given a schema and query templates, the system generates a complete analytical engine in minutes to hours, achieving 11.78x total runtime speedup over DuckDB on TPCH and 9.74x on CEB. The key difference from naive prompting. Generation precedes incrementally storage layer validated before execution logic. Correctness and performance optimization are strictly separated, and a live hot patching infrastructure allows the synthesis process to modify a running engine and immediately observe performance effects. The framework for extracting maximum value from AI-assisted development, meanwhile, is getting formalized. The builder's PRD distills the irreducible human work to about 2.5 hours. Honest self-reflection, one conversation, the scope cut, a USP reality check, a compliance decision, and watching one real user. Everything else is AI territory, if you build the right prompts and force the model to surface its own uncertainty. The Qwen shakeup and open-weight geopolitics. 24 hours after shipping QWEN 3.5, a small model series that drew public praise from Elon Musk for its impressive intelligence density. The project's technical architect Junyang Justin Lin and two colleagues departed Alibaba under unclear circumstances. Lin steered Qwen from a nascent lab project to a global powerhouse with over 600 million downloads. His farewell, me stepping down, by my beloved Qwen. The QWEN 3.5 models themselves are technically significant. A gated DeltaNet hybrid architecture with a 3:1 ratio of linear to full attention, enabling a 9B parameter model to maintain a 262,000 token context window while running natively on laptops and smartphones. Internal reports from a PentAGI conference held on March 4th paint a picture of organizational tension. The primary catalyst appears to be a dismantling of the vertically integrated R&D model Lin championed, splitting the team's closed loop into horizontal modules managed by Alibaba Cloud's PentAGI lab. The reported appointment of Hao Zhu, a Google DeepMind Gemini veteran, signals a shift from research-first to metric-driven leadership. DeepSeek researcher Xinyu Yang captured the concern. Replace the excellent leader with a non-core people from Google Gemini, driven by DAU metrics. If you judge foundation model teams like consumer apps, don't be surprised when the innovation curve flattens. The chief HR officer's rhetoric. Asking staff, what do you think your own cost is? Signals a pivot from talent-first culture to replaceable corporate structure. For the 90,000 plus enterprises deploying Qwen, the immediate future is bright. QWEN 3.5 delivers 60% cost reductions, but the longer-term trajectory of open-weight releases from the most vibrant open-source lab in the East is genuinely uncertain. The parallel to Meta's post-Llama 4 reorganization is hard to miss. The urgency cuts both ways. Adam Kovacs points out that ChatGPT launched 1,191 days ago. 2025 alone saw 31 state-of-the-art model launches, and the capability horizon is expanding faster than most organizations can absorb. His prescription is blunt. Stop carving out time for AI and start doing everything with AI. Saying that you don't have time for AI is an unacceptable excuse. The functional tool use, he argues, is just one part. Achieving real ROI also requires systems thinking, change management, and what he calls the most systematically avoided skill: metacognition, the ability to observe your own thinking, name your gaps accurately, and act on what you find. Tools for the multi-agent era. As agents multiply, the infrastructure to manage them is racing to keep up. Symposium, from the creator of K8CPT, rebuilds agentic orchestration on Kubernetes primitives. Every agent is an ephemeral pod. Every policy is a CRD. Every execution is a job. The key innovation is isolated skill sidecars, instead of dumping every tool into one shared process. Each skill runs in its own sidecar container injected at runtime with ephemeral, least privilege RBAC, that is garbage collected when the run finishes. Give an agent full kubectl access for a troubleshooting run without worrying about leftover permissions. The comparison to in-process frameworks like OpenClaw is stark, where OpenClaw manages state and SQLite and flat files with single instance locks. Symposium uses SCD, CRD-based registries, namespace multi-tenancy, and horizontal scaling. It ships with persona packs. Pre-configured agent bundles you activate with a few key presses. and includes both AK9 terminal UI and a web dashboard. On the developer workflow side, Gitstint solves the collision problem when running multiple AI coding agents on the same repository. Each agent gets its own branch and worktree automatically. Conversations that end, crash, or timeout get whip auto-committed. Conflict detection catches two agents hitting the same file before either merges. Main stays clean until the human reviews, approves, and merges. Zero runtime dependencies. npm install Gitstint and go. Meanwhile, Unsloth's integration with Google Colab now lets developers train LLMs directly in VS Code for free. The 2x plus speedup over vanilla Hugging Face, combined with Colab's free T4 GPU, makes meaningful LoRa experiments accessible to anyone without dedicated hardware. Though Colab's session limits 12 hours max, often less mean checkpointing frequently is essential. Open models, creative platforms, and the end of pseudonymity. A research paper by Lerman, Paleka, Swanson, Ernie, Carlini, and Tramer demonstrates that LLMs can re-identify people from their pseudonymous online activity with alarming accuracy. In open web agent attacks, the system correctly identified 67% of anonymized Hacker News users at 90% precision. In closed-world settings, the pipeline achieved 45.1% recall at 99% precision when linking Hacker News accounts to LinkedIn profiles, compared to 0.1% for traditional baselines. The methodology mirrors skilled human investigation, extracting demographics, interests, writing style, and incidental disclosures from unstructured text, converting them to semantic embeddings, then using LLM reasoning to evaluate candidate matches, but operates at machine speed and scale. The implications cut across every context where pseudonyms serve as shields. Whistleblowers, abuse survivors, dissidents, teenagers experimenting with identity. When combined with expanding government surveillance powers, the UK's Online Safety Act, the EU's proposed message scanning, Canada's Online Harms Act, the infrastructure for mass anonymization is quietly assembling itself. The era of practical obscurity, anonymity that holds because denimization is too costly, is ending. On the creative infrastructure side, Hugging Face's modular diffusers introduces composable building blocks for diffusion pipelines. Instead of monolithic pipeline classes, you mix and match blocks. Text encoding, image encoding, denoising, decoding, that dynamically recompose based on what is present. Custom blocks are publishable to the hub and loadable with trust remote code =true. The Melon integration provides a node-based visual workflow interface where a small set of dynamic nodes automatically adapt their interface based on the selected model. Community adoption is already producing results. Kriya's real-time video 14B parameters, 11 FPS on a single B200 and Overworld's Waypoint 1 2.3B parameter interactive world model both ship as modular blocks. Qt AI's Hibiki Zero adds real-time multilingual speech translation, French, Spanish, Portuguese, and German to English, with voice transfer running on a 3B parameter model that fits in 8 GB VRAM. And OpenClaw offers something entirely different. A persistent virtual city where AI agents live, create music and art, form relationships, and build reputations. Agents publish skills, propose collaborations, and produce artifacts that persist in physical spaces rather than scrolling past in a feed. Up to 500 agents can be active simultaneously, each with their own identity that forms over time. From what you create, who you create with, and how you change.